So just to sum up, I gave you a very quick taste of the start point of a vibration discussion about defining vibration and defining some of the terms that go with that, and showed and mentioned how machine faults show up in different parts of the vibration signal. That amplitude that we get can also be used for machinery protection. And then in the demo, we went through the onboard visualization and then a little bit about some of the options for in-depth analysis. I should actually point out that our product training for Weblog for an expert user, Weblog expert, for the full training is more than a week to get. It's approximately a week for the analysis side of things, and it's approximately a week for the configuration side of things. So you can see it's quite a large product in there, which does a lot of in-depth things. And again, the specific training under the ISO standards, each training course is a week long because there are a lot of different topics to get through within that syllabus. So we've developed that approved training. We've been approved by BINDT, and so we're now available as a trainer for such courses and qualifications, and we'll be offering that as and when the demand requires another course to run. So that's me for today. So if you've got any questions, I'll be quite happy to take them up. And yeah, let's go from there.
Yeah, hello, David. I have a question. Yeah, thank you for the clear presentation and demo. Quick introduction about myself. Ralf Stam, working at automation company MSA Service. But I've also some experience in the condition monitoring field. And I was wondering, so you as Bachmann also have a remote monitoring center, so you supply customers with advice based on the vibrations, right?
That's right. Yes.
Yeah. I was wondering how do you communicate the results with the crew? Do you have like reporting systems or whatever, or is that some automation on it, or how do your advice come to the person who needs it, who needs to take action?
Okay, so the monitoring center here in Rudolstadt, we have a system which we call the Weblog portal, which is an internet-based system. So when we create an event report, we generate a short report highlighting the part of the machine with the problem, highlighting what we think the problem is, what needs to be done, and then that report is put into our ticket system and an email is sent automatically to the crew. Now, as you may know, our monitoring is not purely for the marine branch. And in fact, the majority of our customers at the moment are in the wind branch. I realize that access to an internet from a ship system may be a little bit more complex. So there may be other things we would need to do in order to put that in place. But clearly it's something that we can maybe work out through satellite mobile phone communications or something like that. It's a relatively simple portal to get onto, and it's driven through a simple email system. So I don't know, I have to admit, I don't know how emails work onto ships, but that's the basic delivery mechanism. But then all the information is available within the portal, and you can look through the history of the ticket and get back to your data as well.
Okay, thank you.
Maybe I can add one more thing to that, because in the past we have been connecting thrusters. There are two options here, that it's connected to the internet. As soon as a connection is made, the data is sent and the ticket is triggered. In the case the owner or class doesn't allow us to go directly on the internet, the data file is just stored on a USB stick and sent by hand per email into the ticket system. It just depends on how the owner wants it to be done.
Yeah. clear. Yeah, that's indeed also one of the hassles you need to fix when delivering this kind of service. Just that connection on the one side for the data coming through your analysts, and the other way back. So sending the advice and reports back. But
I completely agree with that. The key to a good condition monitoring system is good communications in both directions, because if you set up condition monitoring and find a few issues on a machine and just send off those issues and then never hear whether you were correct or whether you were too early or too late, then you can never improve your system. So the whole feedback allows continuous improvement.
Yeah, and that's also the training part of the training or the keeping good close contact with the person. Well, in this case, for a vessel, maybe for a windmill, it's different. But for a crew on a vessel, then it's key how they translate the advice into actions or not, or what they, because the analyst knows a lot from the graphs, etc. But not always that much from the process, how the machines are being used, and that cooperation is key to success.
Yeah, that's one of the advantages of the Bachmann system being embedded in the control system. It's relatively easy to bring in certain key parameters about loadings on the machines that you're looking at, speeds that they're running at. Obviously, we get anyway. But you can get more data from the background in order to learn more about the operating conditions and correlate with the operating conditions.
Yeah.
And the CMS Visu that I demonstrated earlier does have the capability of alarming on other parameters in the system rather than just one of the vibration parameters, and can tell you about what else is going on in the system. Haven't got that on the test rig, obviously, but it's available.
Yeah.
David, maybe we can ask one of the other attendees having experience. I see some of our customers using our systems. How do you process the data? How do you inform your customer or your own center, for example? Maybe I can ask this to Alexander Nijdek or to Jan Glas. Maybe they know.
Can you hear me?
Yes, we can hear you.
Perfect. Yeah. So yeah, it's in practical, it's a problem. Yeah, to keep the communication line always active. And yeah, I think the important thing beside the tools you get with, let me say, the weblog and so on, is also to have the internal processes that that you get regularly in touch with the customer, and you have also the correct contact person on customer side and so on. And when we are talking about a continuous monitoring, I think it's also important to have, let me say, some kind of agreement that this whole let me say monitoring process is defined. What are the responsibilities of each side? It's also a problem for us that we can receive the data, so we have also the described way. Okay, the customer needs to download the data on the USB stick and then to provide it to us, and this is something which has to be very clarified with the customer and regular lived in the practical operation. But it's difficult. Yes, I agree.
Thank you, Alexander Nijdek, for helping us out here a little bit. I got a chat, David. We're still seeing your screen with all the faces and the topics.
Maybe you should. Yeah, I'll stop sharing. Sorry. Yeah, there we are.
Yeah. Okay. Perfect. Now we see you. It's getting better.
Maybe I should switch my camera off as well, like everybody else.
Any more questions? Maybe I have one. Gert-Jan.
Yeah, I have one for David. Thank you. David, the training part is interesting for me. So you have a week part analysis and then a week configuration. That's both done in Rudolstadt, right? It's on the premises that you have the training, or is it also combined with some online elements?
We have been doing some online training during the pandemic, so we are moving towards online training for the weblog and the analysis and configuration training. What we find is that trying to do a full week-long training session via the internet, via these sorts of meetings, is not really very good either for the trainer or the trainee. So they've been split into sessions of about 3 hours each, going over specific topics, and maybe streamlining it a little bit as well. So we end up with about 10 3-hour sessions for a company.
And when you finalize a training, do you have like return days, or do you keep the participants together throughout the period after the training is finished, so they can exchange experiences or share ideas or insights? Or is it just, well, this is the training and then it's implementing?
So we tend to do our product training on an individual company basis, because each company has its own processes and procedures, and Weblog is designed to allow you to tailor your procedures to the way you go through the Weblog processes, so that things like the ticket system, different companies will have different requirements. So the product training we tend to keep to single companies at a time. So obviously those people are working with each other anyway. The accredited training, the ISO standard CAT 123, we've only just started with that training, and so far we've only done an internal training, but that is actually an excellent idea, that we should have a sort of a network of people who've gone through the training and who want to exchange experiences. That sounds like a very good idea, and I'll be looking into that for once we start getting more and more different people coming to us, because obviously sharing experience between different industries is also very valuable for condition monitoring. So thank you for that suggestion.
Well, you're welcome. I haven't introduced myself. I'm Gertjan Huizing, co-founder of the LISA community, and that's all what the LISA community is about: sharing information and experiences and connecting the right people. So you have already the possibility within the LISA community to connect some of the people and try to experiment with that. But we can take it up with Ronald if he likes. Thank you.
Yeah, this is our next step. So the first step today was to show a little bit of the tools we have. So the first tool David showed was our onboard visualization. Of course, you need to understand a little bit about the equipment. You never can identify if something is wrong if you don't know, have no reference to it. And I think it's a very good idea to involve the crew on board. These are the first stakeholders beside the machines who need to know what's going on in the machines. We would like to set up some kind of a training program on the LISA community ourselves. Start dealing with the basics and see how we continue there. We'll come back to that. Are there any other questions from the audience?
Yes, Ronald.
Bert.
From me, Bert de Boer here, Quality. We have been talking about, or listening to the possibilities to analyze vibrations. My question is there already a form of event analysis in place in the system? So maybe, for instance, when a pressure pressure transmitter moves through a certain pressure path every so many times, which is not normal, or a pump switches on and off more than it would have to do in a normal situation. So all kind of related operational issues which could lead to damage or could be a sign of something not going well? That's the question.
You're-
Is that clear or is that hazy?
Yeah, no, that's clear. The CMS Visio does have the capability of doing that. There is an alarm page on there which will. I showed it briefly during the demo, and it was just looking at some CMS-related alarms, but it can be related to operating conditions, specific thresholds being exceeded, and that doesn't have to just be it doesn't have to be a vibration. It could be a pressure, it could be temperature, and it will trigger the system to take an extra measurement, so it's got more data about what's going on, and it will generate an alarm that the crew can see.
Okay, so that's already in place also and working on other applications.
Yeah.
Okay.
That's one of the advantages of being built into a control system. There's a lot of opportunities to do that sort of thing.
Clear, thank you.
Ralph, I see you raise your hand.
Yeah, indeed. I had from the presentation a question for David. From the presentation, I understood that your software is also compatible with other condition monitoring hardware providers, and I was wondering, well, how that works. Is there some form of standardization maybe to exchange data, or how does that work together?
Yeah, unfortunately, that's one area that the manufacturers have never really got together on in terms of standardization of formats. We do, as Bachmann, offer what we call the weblog interface, which allows the conversion of data from other formats into the weblog expert system and the weblog portal system. The way that works is we write a data converter running on the time signal from the other company's data, and then post-process that through and put it into the weblog server, which holds all our data. Unfortunately, the vibration community has never really got together on having a single format for data. So virtually every system you buy has a slightly different data format behind it.
Yeah.
But the good news is most of the formats are quite simple to decode, so you can just read them into whatever your own system happens to work with. And I've worked with lots of systems in the past. My background was from the power industry, where we were doing vibration analysis on a single system from 5 or 6 different hardware types, all of which had completely different data formats. But it's not that difficult to bring them all into a single one, fortunately. So we're now developing that in the weblog world, so the weblog interface can take some raw data and post-process it into the same format that we use in our weblog system.
Yeah,
And for example,
oh, sorry.
Sorry, go on.
Yeah, provided that the supplier of this equipment is open about their standard, their data, and that's, well, from my experience, not always the case. So they're sometimes protecting the data format or whatever, that which doesn't allow you in that case to fully integrate it into your solution or into the customer solution.
Well, that is true that some suppliers are more open than others. Bachmann's policy has always been to be pretty open about what we do. So we use a RIF to text format that is relatively well known in the signal processing community. But so far we've not had any major pushback from anybody about reading their data in. Most companies do provide some sort of data export facility. What they tend to protect is their data, is their methods of doing the post-processing. So what they want to protect is their special FFT routines, their envelope analysis, their spike analysis, their GSE peak or whatever they want to happen to use. Yeah. But we use an envelope process based on the raw signal that we're able to read from the that's output by the other systems. So we're not infringing any of the processing copyrights in that way.
Yeah. Okay. Thanks. Clear.
Thanks for that question, Ralph, and also for the comment, because this is sharing data is key, and it's key for both the OEM, for the ship owner, and for the shipyard to improve the quality of the systems. And that's a challenge, but we're still young.
Okay.
Any other questions? Maybe I have one, David. What was wrong with the bearing? You showed us a lot of signals and points and envelope spectrums and so on, but what was
Okay.
actually wrong with the bearing?
So the bearing on our test rig, we've got a specific defect that's been machined in it. So to simulate a crack in a bearing race, there's been a notch machined in the outer race of the bearing. So what you saw on the
and how do you know this? By seeing the trend? Is this experience or?
Well, experience always does help, but I can just quickly show that graph again if I can find my share screen button. Yeah, if I just quickly go back to sharing the screen. So here, for example, you can see there's a lot of, I'll start from the time signal. So this is the actual vibration that you would feel, you would hear, and what you can see in particularly these traces from the affected bearing is there are a lot of spikes in the signal. And if I zoom into these spikes, what we have is a number of repeat impacts. So what we've got is there's been this notch machined in the outer race. So every time a rolling element goes over the notch, you get one of these impacts. Now, it's easy enough to see in the time signal we've got an impact at a certain interval, and then you can relate the interval to how often a roller goes past a defect on the outer race. But what we use in the WebLog Expert, which is used in this trend, is what we call an envelope spectrum, which is basically looking at the repeat frequencies of these impacts. I won't go into the processing here. We talk about that on the courses. But basically, you get this repeat frequency, and you can see here we've overlaid the frequency you would expect from the defect on the outer race on top of the envelope spectrum. So with a little bit of processing, we come very quickly to the frequency that points at what the defect actually is. And within the WebLog system itself, I can just make that a little bit bigger down the side. We can get a whole list of different frequencies relating to different problems. And then if we have an entire machine set up, we'll have those frequencies for every different bearing, different gears, different shafts. So we end up with many, many different frequencies to follow on a complex machine. And this is just a very short and quick way of getting to the one that's actually causing us the problem.
So being able to analyze in detail what's wrong with a bearing or a gearbox or something else, you need to know the details from this bearing. So if you go on the vessel, the crew, you can show the crew that there's something wrong, but because you don't know what kind of bearing is installed within that system, which is installed on board, you need to add this information to your data to be able to analyze what exactly is wrong.
That's right, yes. You'd be able to say, oh, that's probably a bearing fault, but you wouldn't be able to say which bearing it was unless you had a list of the defect frequencies. So it's much easier after we've done this post-processing to extract those frequencies and compare them with a list of what we have as likely candidates.
So that also learns us that if we install such a system on board of the vessel, we can say there's something wrong with the bearing. And then if you are a specialist, a mechanic, you probably understand what's wrong. You can decide to order a new bearing and exactly the right one. And if you're not, you would call for help from shore, from your shore support, to identify what is exactly wrong in this equipment. Or is it even less specific that you don't know that there's a failure in the bearing, but maybe just a failure in the pump?
It would depend on the type of failure that you were looking at. So mostly with a rolling element bearing failure, you could probably say, yes, that's likely to be a rolling element bearing problem, but most systems have at least one bearing at each end, and sometimes they have two bearings at each end, one thrust bearing and one radial bearing. So you need to be able to distinguish between which bearing it actually is. And then if you have something like a gearbox, there'll maybe be 6, 8 bearings in a gearbox. So there's quite a lot of decisions to be made to find out the right bearing to change.
Okay. Any more questions from the audience?
No, I have again one.
Sure, Bert.
Is there a possibility to, how you say it in English, that the system is self-learning, that from a new situation, let's say, okay, the spectrum of this machine, when it's completely correct and new, looks like this, and that the system can recognize changes compared to the new situation?
We are certainly investigating those capabilities. It's not that straightforward to do. As you might imagine, it's quite an in-depth processing challenge to do that, especially with spectra, because for various reasons, a single spectrum doesn't come from a unique sort of time signal. So we can do some things along those lines, but mainly what we're doing in the weblog system is picking out a narrow band frequency and using that to detect a specific fault frequency. We can apply the machine learning levels to those narrow band frequencies. We've also done a little bit about machine learning techniques to the overall values coming out of the vibration, but that's more of a anomaly detection, so it becomes easier and more sensitive to when something is changed, but it won't necessarily go to what's changed.
So there is some kind of machine learning capability in the system?
Not yet, but we're working on it. So we've got it in the background.
We can maybe give you a little bit more details later, but first I would like to give Olaf the floor. Is also a question. Is this Olaf?
Yes. Thank you. Yeah. And of course, Tech, we are located in Singapore. We are at the last stages of having a shaft power meter based on Bachmann's platform in the field. Actually, we hope starting sales in for 3 months. It is for 2-stroke engines, David. So therefore, we talk about slide bearings, no roller bearings. With this shaft power meter, we also record the torsional vibrations of the shaft. And my question basically is, do you have some experience in this regard? Does it make sense to talk a little bit further? What can be found? How it can help operators in the marine with 2-stroke engines? What can be detected in addition to any unbalancing between the cylinders?
I'm sorry, your line wasn't terribly clear there, but I think I got the gist of it. You've got a power meter which takes the torque from the shaft from 2-stroke engines. So
Correct.
Clearly that's a very useful measurement to have. I think one of the things I pointed out early on is that vibration is popular because it does a lot of different things. But there's always a place as well for specific things like power meters on the shafts. So there will be certain items you can get from the power meter on the shaft, which are probably easier from the power meter on the shaft than they are from other from vibration signals.
We get the RPM, the rotation speed, also in a very high resolution. So therefore, torsional vibration analysis.
Yeah, the torsional vibration analysis is a different topic to the bodily vibration analysis because it's purely on the rotor, and it's an interesting topic and a useful topic particularly if you've got certain failure modes that occur on your machine. So obviously on a propeller system, you may have certain failure modes regarding the a natural frequency along the length of the propeller shaft and things like that. So our system would be able to read data from such meters and put it next to our vibration data so that everything could be brought together. So that can sometimes tell you about cause and effect. So an unbalanced shaft may have a higher torsional oscillation as well as a bodily vibration as well. So it's always useful to be able to bring different techniques together and look at things in the round and learn more about a machine. As we discussed in the earlier seminars, it's all about the failure modes and effects analysis so that you can identify the cost benefit from applying the right techniques in the right places. And if a shaft power meter is going to tell us something that's going to save us a lot of money, then that's going to be important to include in the whole condition monitoring system.
Okay.
I hope that answers the question.
Maybe I just go back to the question from Bet, because it all seems that combining a lot of information, a lot of data would help. And Bet was relating, I think, earlier to machine learning, and I would like to invite Jacco to say something about that, because actually we are thinking of this. A wind turbine is installed, is connected, so we can adjust all the parameters very easily. A vessel isn't. So Jacco, can you say something about your ideas here?
Yes, of course. Yeah, we have several ideas for this. So an idea could be that on the PLC where we are training a specific machine learning algorithm to take in to train it for a week on the data that's available on the controller. Then after that week, we check whether the system is changing from that machine learning model. So we have several machine learning techniques for that, and that's what we are currently looking into that, and we'll see what's the possibilities are there.
So as you're here, we are thinking of this specific also because of the nature of the vessels. We also think that everybody needs to prepare themselves a little bit better for maintenance purposes, so that we've learned from previous sessions that sometimes we look at the wrong bearings. So the first time to repair isn't always that successful. And installing such a machine learning addition could also prevent something like this happening. It's almost 11 o'clock now, so our hour is gone. It doesn't mean that you have to go, but for those who would like to go, I will give them the opportunity. I also want to ask in the group, is there so most of you are already joining our premium members group within the LISA community. This is the place where we keep you informed and we keep you posted. On Friday within the LISA community, there's a very special day. It's the first year anniversary of the LISA community. And there's every 30 minutes, there's a new, let's say, walk-in session with all kinds of very interesting topics. We, as Bachmann, attend this as well. And one of the topics may relate a little bit to this, namely security on board of vessels, how to get your data without opening it up to all who want to use it for some other reasons. Would be interesting. Before we close this session, I would like to ask, is there any more question from your side? Does this answers the questions to the Smart Maintenance 2 event, showing what we can offer you on board and what we can offer you additional? I would like to thank you all. And I hope to see you at our next event. And this on smart maintenance will be on detailed on training, what we can offer you there.